Hey, sister. So, little ghetto tonight, but I can't find my good video camera. I'm hoping that somebody didn't walk off with it. Hoping it's in my bag at home. But anyway, I wanted to get this to you sooner rather than later. I think we can get the distributive property explained using geometry. Basically, just all you got to know is that length times width is area. I don't know what level students you're working with, but I think most students have this idea even if they haven't had a formal geometry class yet. So this is the way that always has seemed to make sense to most students when I try to explain distributive property. So what I'm going to do is I'm going to trace out a 10 by 10 square on this grid. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, let's see if I can do this right. Okay, there you go. So if it's 10 on this side and 10 on that side, and it's a square, then your area is going to be 100 square units. So just you can count up all those little individual square units, 100 square units. And so looking at the area this way, your area is going to be 10 times 10 is 100. Okay, what the distributive property allows you to do is to take that square and cut it in as many different pieces as you want. So just to give you an example, I'll use red. You can chop it here, and then you can also chop it, we'll make it a different size, chop it here. And what that does, it's like Finland. What that does is the overall square still has the same area, but what you've done is you've chopped the tens into smaller increments. This one's now 1, 2, 3, 4, 5, 6. This piece here is 6. This piece here is 4. Okay? This piece here, 1, 2, 3, 4, 5, 6, 7. This is 7. And this piece here must be 3. So now what you can do to find the area of the whole square is add up the individual piece areas. Now, the formula for areas is still the same, whether it's one big square or the 4 individual pieces. So each piece is going to be length times width. So this one here is 6 times 7, which is 42. This one up here is 4 times 7, because remember, this 7 carries up to here and up to here. So 4 times 7, or 28. This little guy over here is 4 times 3, or 12. And this guy right here is 6 times 3, or 18. And then what you can do is you can add up all of the areas. So you can go 28 plus 12 plus 42 plus 18. And that's 40 and that's 60. That equals 100. Which, I mean, you knew it was going to equal 100, right? I mean, it makes sense that it equals 100. But what you want to look at, not so much is that is what it is, but look what it started as. Really, this started as 10 times 10. It's just that this 10 over here is really 6 plus 4. And this 10 down here is 7 times 3. So what you have is, 7 plus 3, sorry. So what you have is you've got each of these products is one of the pairs of the distribution here. So 6 times 7 is this piece down here. 6 times 7 is that 42. 6 times 3 is this piece right here. It's that 18. 4 times 7 is going to be that one times that one. 4 times 7, that's your 28. And then 4 times 3 is that last little bit, it's that 12. So that's why you can distribute the multiplication to the main square by breaking it up into little pieces. So that's an explanation if you want to break it that way. I just realized something. I probably shouldn't have done this case before doing a simpler case. Let me back up. And I don't know if you're going to give this video to the kiddos or if you're going to explain it to them after you watch it. But here's a simpler way of looking at it. Same square for starters. So 10 by 10, still 10. This time, let me make it even simpler and just draw one line, I don't know, this way. Okay, so that makes, this is still 10 down here, but now this one here is 2 by 8. It's 2 here and 8 here. So it's the same logic. The area of the square is still 10 times 10. It's just that you can write this 10 as 8 plus 2. Now the reason I'm writing it in parentheses is to make sure that if I was to do the area by adding that 8 plus that 2, I would do that first. So 8 plus 2 times 10, distributive property tells us we have to distribute the 10 to the 8 and then to the 2. And that seems like magic to students. So you can actually see it here. The reason you're distributing it is because this 10 times that 8 gives you 8 times 10 or 80. And that would be this. And then that 2 times that 10 gives you the 20. Which would be that. So that's an even simpler way of looking at distribution. What's so cool about it is you can do distribution, you can add as many horizontal and vertical lines as you want. Like this is a silly example, but you could actually cut twice, 3 times, 4 times, whatever you want. Where it really is helpful goes well beyond that. I gave you an example. That's how we taught Max how to do annoying multiplication problems. I'll give you a quick example of why. If you need to get a mental idea of multiplication, you could do something like 98 times 14. Okay, now you can do that with a calculator for sure, but you can also do 98 times 14 and say, okay, well, 98 is 100 minus 2, and 14 is 15 minus 1. And if you're comfortable enough with distribution, you can realize you've got to multiply each one of these times each one of these and then keep track of everything. So 100 times 15 is 1500. Negative 2 times 15 is minus 30. 100 times negative 1 is minus 100. And negative 2 times negative 1 is positive 2. And then you just put all this stuff together and figure out that it's going to be, what's that going to be? 1370 plus 2, 1372. So it's a really neat, you can use it for a lot of things. Since you're doing an algebra class, I'm guessing you're probably going to do it more with variables, but I mean, once they understand the basic principle of how it works with numbers, variables should be, I hope anyway, more straightforward. So I hope this helps, dude. I'm going to get this uploaded today so you have it, and I hope it helps the kiddos. Let me know if you need anything else, okay? Rock on, my friend. Thank you for your help.